Personal finance practice problem using Excel. Fees, long-term costs. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information's on the left-hand side. We're going to populate that into the blue area on the right-hand side, looking into the cost of fees. When we're thinking about our financial institutions, we might have some small fees for particular things. We might think those small fees are not a big deal, and they may not be if we only incur them at one time or something like that. But if we incur them constantly, then they can add up. And so we'll give an example of problem just to think about how small fees can add up and can be a significant to our decision-making process. So we're going to assume here that the ATM fees per transactions are $3, possibly the ATM fees being an item when we go to an ATM that's not associated possibly with our institution, and that could result in a banking institution which may have less ATMs around us than other institutions or something like that. But in any case, we're going to say that we got this fee that we're being charged when we do a particular transaction such as ATMs. Now, if it was a one-time thing, it'd be $3, not a big deal. But if it's a constant thing, and say you do it like even 100 times in a year, then how much could that add up to if we were to do it, say, for 9 years? We'll just pick 9 years as the period, and we'll think about it in terms of no time value of money, and then we'll think about the time value of money consequences included in that as well. So let's just think about the total cost if over 9 years of $3 a transaction, and we do 100 of them a year. So let's just say, okay, well, that means that the ATM fees here would be equal to the $3, and we do that 100 times. 100 times we go to the ATM, and we go to the ATM that's not at our bank because it's closer, and we pay the $3, and we say that's not a big deal, $3, and it's not really if we do it a one-time thing, but font group underline, and then we're going to say cost per year then is going to be 300, 3 times 100, starting to get, a little bit more expensive. And then if I was to do that for 9 years, so if we did that for 9 years, we just kept on going to the ATM that's not at our actual institution and paying the charge of $3 every time, 100 times a year, then the total cost, not considering time value of money, we're going to say is going to be equal to 300 times the 9, or the 2007, which gets significant over 9 years to 2007. So we can say, okay, that starts to add up. What if we were to add time value of money? What if we were to take, instead of that $3 charge that we're having here, we took that, we put it into a savings account or an investment account? We're going to assume a rate of return at 7%, which you might get at stocks and bonds or something like that, and say, look, what if we take in time value of money? How much would that charge be worth it to us? Meaning, what if I was able to take that $300 a year, put it into an investment, and generate 7% for that 9-year time period? Where would we be in terms of future value dollars at that point? So we then could say, let's take the negative future value, shift 9. The rate is going to be this 7%, and then comma, the number of periods is going to be 9, compounding yearly for 9 years, comma. The payment is going to be the 300 because it's the $3 times the 100 transactions, which we could pick up down here. Or we can say I'm going to take that 3 times the 100 and enter. So that would be a future value of the $3,593. Let's just work that out with our annuity table over here just to see it in terms of an annuity table, or a table that will break out as we could see the increase in the payments. So I'm going to take 1 and 2, select those 2 items, put our cursor on the autofill handle, drag it on down, center that by going to the Home tab, Alignment and Center. We're going to say that the payments, we're going to have payments each year, which is going to be that 300, which once again was the $3 times the 100 that we're going to assume. What if we took that money and put it instead on a yearly basis into an account that we're going to get a 7% increase on? The balance at year 1 is going to be 300. We'll start the annuity down here. We're going to say this is going to be equal to the 300 times the 7% increase. I'm going to select F4 on the keyboard so I can copy that down. By the way, I know I'm doing this a little bit quickly because we have seen these types of problems, present value, future value problems in the past. Now we're just applying these concepts to this particular situation. So if you want to work on these kind of present value problems and future value, time value of money problems in more detail, more slowly, then take a look at a prior section where we look at time value of money specifically. So that's about $21. And then the payment's going to be the same, which I could say equals the item above it, so that I can copy that down and it will always be the cell above it. And I'll then say that this is going to be equal to the prior balance plus the SUM, the sum shift 9, left arrow of these two, and then closing that up. So I'm just going to say the 21 plus the 300 plus the 300 means that after the second period, we would be at that 621. Let's do it again. We're going to say, we'll do it a couple more times, then we'll do the good old autofill. So this is going to be equal to the 621 times the 7%. If I was to copy it down, I would want to make that an absolute reference because there's a cell outside my table. F4 on the keyboard, $ before the B and the 5. Tab, the payment's always going to be the same. I'm going to say equals the item above it. When I copy that down, it'll always be the item above it, and we'll always have that 300 going on down. The ending balance is going to be equal to the one above it. That's going to be the prior balance plus the SUM, sum, shift 9, left arrow, selecting those two items, the 43, the 300, closing this thing up, shift 0. So we're taking the 621 prior balance plus the increase of the earnings, the 43 plus the 300 that we would be putting in year 3, giving us an ending balance of the 964. Let's do it one more time, then we'll do the autofill feature. This is going to be equal to the 964 times the 7%, F4 on the keyboard, and enter. And then we're going to say this is going to be equal to the item above it, the 300 above, and enter. And then this one is going to be equal to the 964 prior balance plus what happened in this time period, the SUM, shift 9, left arrow, holding down shift, left again, shift 0, closing it up, the 964 plus the 68 plus the 300, giving us the 1,332. I'm actually going to delete this stuff now, and so we can do it again, this time keeping the autofill feature in mind, so we can just autofill it down the easy way. I'm going to put my cursor on the 21 down to the 1,333 and delete it. What? You're going to delete it? Yeah, there it goes. Undo. No. We're going to do it again. So it's going to be, this is going to be equal to the 300 times the 7%. And notice I'm going to select F4 now because we're going to copy it down this time for reals. So we're going to say F4 on the keyboard. We got a $ before the B and the 5. We're going to say tab. The payment is going to be equal to the item above it, bringing the 300 down each time we copy it on down. Enter or tab. This will be equal to the prior balance of the 300 plus the SUM, sum, shift 9, left arrow, holding down shift, left again, holding down shift 0, closing it up, the 300 plus the 300 plus the 21. Nothing needs to be an absolute reference there because we're all in the table. So these are going to copy down automatically, as will the 300. So we're then going to select these 3 cells, put our cursor on the fill handle, and drag it down. And so there we have it, bringing it down to the 3,593. Once again, that would be our future value. Now, just to be fair, notice you might be sitting there saying, hey, well, wait a second, because even if you value it at the 2,700, you've got payments that are happening in the future. Maybe you should be bringing that back to the present value to see how much it's worth, in terms of the present value dollars. So you could try to do a present value calculation, present value, in a similar fashion. We'll add it down here, and that would be the negative present value, shift 9. The rate would be the 7%, comma, number of periods would be the 9 periods, and then comma, and then we have this annuity, which would be the $300, which we're going to take then the 100 here times the 3, and so there we have it. So that would be present value terms of the 1,955. I'm going to go ahead and say let's make that here, and so we're going to say this is going to be blue, and there. So in other words, you might, if you were trying to emphasize the fact, which we kind of are here, that the $3 is, even though it looks small, can result in a substantial cost in the future, you could say, okay, I'm going to take the $3 like we did here times the 100 transactions gets us 300 times 9. That would be the cost, and that doesn't even include the time value of money. And then we added the time value of money to give us the future value, how much money we would have if we were to take that money and put it into an investment, giving us the future value. But you might be saying, well, wait a second, even that 2,700, you're talking about costs that are in the future. So if I'm bringing it back to present value dollars, you would think that I should be present value in that to show me the amount of the cash flow that's actually happening in terms of present value dollars in order to be fair, because that 2,700 represents money that's going out basically in the future. So you might bring it back and say that the present value is actually only the 1,955. Another way you can kind of see that is if we took the present value of this. Notice this 3,593 represents the future value after 9 years, how much money we would have in a future value. But maybe it would be more fair to also look at that in terms of where would we be in terms of today's dollars, present value dollars. So we could bring this annuity calculation back to today by doing a present value of 1 calculation, which would look like this. Negative present value, shift 9. The rate would be then this 7%, comma. Number of periods would then be 9 periods, and then comma, and then we'd get another comma because this is not an annuity, present value of 1. Therefore, we're going to pick the future value of that 3,593 and enter, and we get to that same 1,955. Let's put a bracket around that. Let's call that the present value. And so we can then go and make that, format that for us. So you can see it a couple different ways here. So, and just realize what the main thing we want to point out here is, of course, that the small fees can add up, and they are significant. So if you want to make sure that you're avoiding minimum fee balances if you can, to make sure you are at an institution that has an appropriate minimum fee that you can pay as little for just the service of the checking account, as well as ATM fees and that kind of stuff. Also, just note that when you're looking at people that are trying to use numbers to make a point, then it's nice to try to be fair about it, right? You're trying to look at the future value in order to make the number look bigger, and that's fine, but you should also basically kind of present value, bringing it back, so you can look at both sides of the argument whenever you're thinking about these types of things. You can kind of see how people might put the numbers together to fit their argument and try to just look at it in a more objective way as well.